So on the quiz that we had most recently, we had these different functions named f of x, g of x, h of x, and they asked us to do different operations with those functions. This is just the notation for taking your f of x function and subtracting your g of x function with it. So let's first understand that the notation means to take your f of x function and subtract your g of x function from it. So the f of x function is really the 2x plus 3, and you can put that in parentheses if you want. And the g of x function is x minus 1. And of course we are subtracting both of these. It's important that we use parentheses, that way we remember to distribute the minus sign right there and right there. So when I distribute the minus sign to the x, that becomes negative x. To the minus 1, it becomes plus 1. So what I really have is 2x plus 3 minus x plus 1. So if I combine the 2x with the minus x, I'll get x. If I combine the 3 with the 1, I'll get 4. So x plus 4 is the final answer there. A lot of people forgot to distribute the minus sign, and that's an easy point that you shouldn't get wrong. So please don't make that mistake on the quiz tomorrow. Let's look at number 2. We have h over g of x. What does this mean? Take your h of x function and put it over the g of x function. Divide or reduce if possible. So when I take my h of x function, that's x plus 5, and I put that over my g of x function, which is x minus 1, and then there's nothing to cancel, there's nothing to reduce. That's your answer right there. The only other thing you have to do is say that x cannot be 1. Why not? Because if x were a 1, 1 take away 1 is 0, and it would make it all undefined. So this is your answer, but we also need this right next to it. X cannot equal whatever this is. If it were x minus 3, then x could not be 3. If it were x plus 2, then x could not be negative 2. So that's how you determine what x could not be. Anyhow, let's do a couple of more problems with these same 3 functions. Number 3 reads to input the negative 6 into your h function, and because it's a number, you're going to be able to input it and get an actual numeric answer. Then you take that numeric answer and plug it into the f of x function. So let's start by doing this inside part. I'm going to rewrite it. H of negative 6. Well, actually, I should have written this in green because the h function is in green. So the green function reads x plus 5, and we are inputting the negative 6. So h of negative 6 is really negative 6 plus 5, which is negative 1. So what I'm saying here is that the h of negative 6, that's really negative 1. Do we all agree? Mm-hmm. So what we have now is really f of that answer that we just got, negative 1. So we're going to plug in the negative 1 into the f of x function. The f of x function reads 2 times x plus 3, and we said that we are plugging in a negative 1 right in there. That's what f of negative 1 tells you to do. So let's do the math here. 2 times negative 1, that's negative 2, and negative 2 plus 3 is 1. So what is f of h of negative 6? It's all equal to the nice, beautiful number 1. Now, number 4 has no number to plug in. It actually has a function, h of x, that's green, which is a variable expression, that you're going to plug into the g of x function, which is red. In parentheses, you plug it in and then do the math. And then once you get that variable expression simplified, you're going to plug in that variable expression into the f of x function and then simplify. So let's begin with the g of h of x. So g of h of x is really taking the green and plugging it into the red. So I'm going to rewrite the red one. The red one is x minus 1, and in those parentheses I'm going to put that x plus 5. There is nothing to distribute, so you don't really need those parentheses. That's kind of like saying x plus 5 minus 1, so that's just a x plus 4. So do we agree that this part, g of h of x, that's all really x plus 4? I hope so. So now let's put that f of that x plus 4, and we're going to plug in x plus 4 into the f function. So plugging in x plus 4 into the f function, that reads 2x plus 3, 2x plus 3, and we are plugging in x plus 4 where the x used to be at, where the parentheses are. Distribute, combine like terms, you'll be done. Final answer, 2x plus 11. So there's going to be some of those on the quiz tomorrow, all review, basic stuff. There's also going to be one where I ask you to find the inverse. So here's an inverse notation. Find the inverse of f of x. Well, remember, let's begin by saying that f of x is really the same thing as y. So I could say y equals 2x plus 3 instead of f of x equals 2x plus 3. Now, how do we actually find the inverse? Do you guys remember how to do that? Switch the x and the y, and then solve for y. Okay, so let's start by switching. That y becomes an x, that x becomes a y, and now let's solve for y. So let's get y by itself on the right side, minus 3, rewrite it, x minus 3 equals 2y, divide by 2, and there's your inverse function. This is your inverse function. So you could technically write it over f with the little negative 1 of x. That's your inverse x minus 3 over 2. Or you could have even said this, y with the little negative 1. You could also call that inverse x minus 3 over 2. And you could also divide or separate the division of 2 to each of those. So you could recognize that there's a 1 in front of the x, and when you split that 2, it'll become a 1/2 x minus 3/2. You could do that if you want to. You don't have to. The original one's already good enough. So that's the old quiz that we took, that we did good on, that we're going to do better on. And then there's going to be a new part of the quiz, which is graphing radical functions. We should remember that graphing radical functions, it's pretty much similar to graphing parabolas the way it looks. The a value causes a vertical stretch if it's bigger than 1, or a compression if it's a fraction less than 1. The h and the k will tell you your beginning point. Right here you'd think opposite of what you see because of this minus h. But we are going to do this worksheet today that has more interesting questions. What do I mean by more interesting questions? We're going to have a worksheet where there's an actual number in front of the x. So we're going to have a number in here, not out here as the a value, but a number in front of the x. Let me hand out this worksheet. So check this out, guys. Here's the worksheet that you just got. This worksheet has some questions that are straightforward, stuff that we've done, like number 6, right? And remember how to do this. You box this in, ignoring h and k. You make your xy table, get some coordinates, and then after you get those coordinates, you shift them 4 units to the left and 2 units down based on your h and k. But let's go to something more interesting. Check this out. We've done something like number 3 where the a value is 2. That's not really that interesting. It gets interesting where there is a number in front of x. Now that gets really interesting, right? There is no a value, but there is a number in front of x. So think about this, guys. The beauty of an input-output table is that you could plug in any number you want. Any number you want. So if we're dealing with the square root, what would be nice to take the square root of? It'd be nice to take the square root of 0. But in here I have a 2 times something. So what would this something have to be in order for it to be a 0? 0. So 0 is a great value to plug in, because when you plug it in right here, 2 times 0 is 0, and the square root of 0 is what? 0. Okay. What would be another nice number to have right here so we could, forget about the 2x right now. What would be nice to take the square root of? 1, right? 1 would be nice. I mean 4 also, but let's go with 1 first. How the heck could I make this a 1? 2 times what is 1? Half. So you could plug in any number you want, including fractions. You could plug in a half. And if you do plug in half, 2 times half is 1, and the square root of 1 is 1. So you actually get a coordinate 1/2 comma 1. So the next one, yeah, it'd be nice if we had a 4 right here, and that would be a 2, because 2 times 2 would give you the 4. So let's plug in that 2 that would give us a 4, because 2 times 2 is 4, that we could do the square root of 4 that gives us 2 as an answer. What other perfect square number would be nice to end up with right here? A 9 would be nice. How could we change this 2x to become a 9 if this x was a what? 4.5, 4.5. So let's put 4.5 right here as the input, and 4.5 times that 2 will give us 9, and the square root of 9 is 3. How about the next perfect square number after 9? What would that be? 16. Could I change this 2x to a 16? Yeah, by changing that x to a what? 8. So if I input 8, my output will be, well, that'll be a 16. Square root of 16 is 4. So I just wanted to show you this one. I will not give you this one on the quiz tomorrow, but I just want to show it to you because it's very interesting, especially the way input-output tables, you could plug in any number you want, and that'll make it good for you. So let's graph it. 0, 0 is right here. 1/2 on the x and 1 on the y is right there. 2 and 2 is right there. 1.5 and 3, no wait, 4.5 and 3 is up here, and 8 and 4 is right there. So let's connect those dots and we have our graph. We could do 2, but you know what? For the assignment, we're going to skip 2 on the assignment. We're not going to do it. You guys should be able to do 3, and you should expect something like 3 on the quiz tomorrow, right? It's pretty easy. That's the A value of 2. We know that causes a vertical stretch. So do number 3, check your answer in the back. You're not going to really see something like 5, but it's interesting. Let's do that one together right here. Especially because, before doing 5, 6, you might see 6 on the test, or on the quiz tomorrow for sure. What is the H value on number 6? -4. What's the K value? -2. Now, if we look at this guy right here, the H value is not 5. Weird, huh? The H value is not 5. Okay. You see, over here, what's the H value? -3. Now, the reason why when we look at H, when we look at this value, and we say H will be the opposite of what we see here, it's because there's no number here in the front. And because of this minus sign, we think opposite of what we see. So right here, yeah, H is -3. But that's because there's no number in the front. There's no number in front of X. So I want to take it to a deeper understanding here. There is a number in front of X. So the H is not -5. In order to find H, you would have to set this whole thing equal to 0 and then solve to see what H is. So over here, the same thing. If I take X plus 3 and set it equal to 0, subtract 3, yeah, H is -3. But that's really easy to just think opposite because there's no number in the front. But over here, if you wanted to find out what your H value really is, you're going to have to do 2x minus 5 equal to 0 and find out what that H value really is. You would add 5 to both sides. You'd end up with 2x equals 5, which means that your H value is really 5 over 2, which is really 2.5. And it's positive 2.5, which means you're going to be shifting 2.5 units to the right. Does that make sense? So we're going to box in our function, ignoring the other numbers, the H and K, if there is any. And we're going to make an XY table. And we're going to plug in numbers that work for us. So it would be nice if I could do the square root of 0. That could be done by making that x 0. By inputting the x value of 0, that'll make it 2 times 0, which is 0, and the square root of 0 is 0. With the negative in front, that's a -0, which is still 0. It would also be nice to get a 1 in here. So to get a 1 in here, this fraction, or this x, would have to be the fraction 1/2. 2 times 1/2 would be 1. So I would like to plug in the input 1/2. When I plug in 1/2, 2 times 1/2 is 1, and the square root of 1 is 1, but with the negative in front, that'll give me the output of a -1. It would also be nice if I could get a 4 right here, and I could get a 4 by inputting 2. So if I input 2, that'll give me a 4, and the square root of 4 is 2. With the negative in front, that would be a negative 2. It would also be nice if I could make this a 9. That way I could do the square root of 9. And I could make this a 9 if this were a 4.5. So if I put a 4.5 right in there, 4.5 right in there, I'll get the 9 that I want, and the square root of 9 is 3, but with the negative in front, that'll be a negative 3. Let's even go one more further. I would like a square root of 16 in here. I could make this a 16 by inputting an 8 right there. So if I input an 8, I'll get 16, and the square root of 16 is 4 with the negative in front. That'll be a negative 4. So let's graph these coordinates. 0, 0 is right here. 1/2 and negative 1. Halfway on the x, negative 1 on the y is right here. 2, negative 2 would be down here. 4.5 and negative 3, that'd be 4.5, and then 1, 2, 3 down, that'd be right here. And 8 and negative 4 would be down here, 8, negative 4. Now, I am not going to graph my graph through these coordinates. Why not? Because it's not my final coordinates. This is so far just the boxed in portion. I still need a shift according to h and k. There is no k, but we did say that the h was not 5, but what was it really? 2.5. So I need to take each one of these coordinates and shift them 2.5 units to the right. So I'm going to go 1 unit, 2 units, and then halfway right there to 2.5. This one, 2.5 units. So here's half, and then 1, 2 will be right there. This one, 2.5 units. 1 unit, 2 units, and then halfway more, it'll be right there. This one, 2.5 units. This is half, so there's my half, and then 1, 2, it'll be right there. The last one, shift it 1 unit, 2 units, and then halfway. It's off the graph. I would still put it just to get reference of where my graph is going to be pointing at. So it begins right here, and it goes in this direction, and then you could put it pointing towards that one that's off the graph. So my beginning point is right here. What is this location? What is this coordinate? What's that coordinate, guys?
What?
2.5 comma 0, right? So if I'm talking domain and range, what would my domain of this guy be? X is greater than or equal to that 2.5 that you started with. And how about the range? The range would be y is less than or equal to the y value of the beginning point, which is 0. Will you have this on the quiz tomorrow or no? So why am I teaching you this stuff? Well, because it's probably going to be on the CASP. It might be on the final exam, right? What are you going to see on the quiz tomorrow? Yeah, something like this. Something straightforward where you could clearly see that the H is opposite of what you see here. The K, take it for what it is. You might even have an A value out here on the outside. Here's another thing that's very important that you might see on a final exam that you're not really going to see on tomorrow's quiz. It's a square root function that's an inequality, okay? So you would do this the way you normally would, like if it were a regular equation like y equals the square root of x plus 1. Of course, you would identify your h and your k. What's your h and your k on this one? Negative 1 and 0, okay. Now, we usually box in and come up with the input-output table, and that's just your parent graph. It's really easy to find inputs and outputs to the square root of x. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And we're going to shift all of these where? 1 unit to the right. Left.
I was like, what?
H is negative 1, so we're going to be shifting to the left. So let's plot these points. 0, 0, 1, 1, 4, 2, and 9's off the graph, so I'm not even going to do that. You know what? I should.
It's like on the line.
9, 3, 6, 7, 8, 9 is off. 1, 2, 3. So we're 1 unit off, but there we are on the outside. Now we're going to shift all of these 1 unit to the left. So here's your dot. Let me do it in blue though. Here's your dot. 1 unit to the left, 1 unit to the left, 1 unit to the left. So our actual graph starts off at the coordinate -1, 0, and it goes off in this direction. Now, before drawing it, because it's an inequality, I need to determine whether it's going to be a solid graph or a dotted graph. What do you guys think? Solid because there's a solid line underneath it. So let's go ahead and do it solid. And remember, when you graph an inequality, you also have to shade. Your answers are either going to be on one side of the graph or the other side of the graph. The shortcut is the easiest way to do it. Are you going to shade in above this curve or below this curve? Above, because it's a greater than or equal to. All right? So how would you shade this? You got to go to this beginning point and shade directly above. Don't go to the left because the graph does not exist to the left. It's directly above. So if you have a highlighter, you would just go directly above, and all of this would be shaded in above. Now, if this would have said less than or equal to, then it'd be solid and you'd be shading everything below. But you have to stick to this line right here. Don't go on this side of the line. This is your beginning point. This is your beginning x value, and it's over here on this side. So that's another important question that you might see on a final exam. You're not going to see it on the quiz. You might even see it on the Chapter 6 test. But on tomorrow's quiz, we're not going to be shading. We're not going to be having inequalities. Okay, it was brought to my attention. I made a mistake. I did. This point that was off the graph by 1 unit, I should have moved it only 1 unit over, having that point right here, not over here. Okay, so just to let you know, the blue dot should have been over here. Yeah, I can't even erase it anymore. So here's let me do it in a different color. Starts here in green, goes off through that point. Not that blue one anymore. Scratch that off. So again, I repeat, this will not be on the quiz tomorrow, but it's important to know. What are we going to see on the quiz tomorrow? Something like number 6, something like number 3, something like number 4. So you guys have the rest of the class to do the rest of these. Do numbers 3, 4, 6, and 7 or 9. 7 and 9. Go for it.